Okay, so we'll just get through the warm up real quick since I already went over it in class. But basically, for an angle that's 120 degrees, this top one would be 90. This would be 180 degrees. We're looking somewhere in between. 120 is 30 past 90. 90 is going to be, this whole thing's going to be 90, right? And 30 is 1/3 of 90. So we're looking at about a third of the way from 90 to 180. So something like that. Negative 120, the only difference with negative angles is you go downward in around the, or I should say you go clockwise around the origin rather than counterclockwise, which is what we normally do. In other words, like you start by going down instead of up. So we're going to have the same situation. We're going to end up with an angle that's about a third of the way towards negative 180. And then 480 is the same as 360 plus 120. And the reason I say it like that is because once we do 360 degrees, we end up back at our starting point. And once we're back at our starting point, then we're just, to figure out where our angle lands, it's just going to be 120 degrees. We already figured out where 120 degrees is. It is right here or so. So that's about 120 or 480 degree angle. And the reason for this is that 480 and 120 are coterminal angles, meaning they end in the same spot. So let's see, on this one, we're looking for a coterminal angle for 225 that's positive and one that's negative. So let's sketch it first. 225, well, if this is 90 and this is 180, then and this is 270, then we're going to be somewhere in this quadrant, right? Between 180 and 270, 225. So we want to find a pot. Oh, first we want to find it. So 180 to 270, that's 90 degrees, right? 180 to 225, that's 40 degrees. 225 minus 180 equals 45. 45 degrees is half of 90, which means we're going halfway from 180 to 270. So that's going to be your 225 degree angle. And then to find a coterminal angle, we're just going to add 360 to that, which would be 585. You could add 720 or 1080, just as long as it's a full circle around. That would be 360. That would be 720. That would be 1080. I think the next one's like 1440 would be another full circle. But anyway, you add 360 and you get like 585. And then a negative coterminal angle, well, that would just be like going from here backwards the way we came and subtracting 360. So you're still making a full circle back to where you started, but you're doing it with subtraction instead of adding. So you could subtract 360, you could subtract 720, etc., etc. So 225 minus 360 is negative 135. So now we're finding the reference angle for a 225 degree angle. So remember, we're down here. And we want to draw a perpendicular line to the x-axis. Right, so this is our x-axis, this is the y-axis. So we're going to draw a perpendicular line to the x-axis. Let's do a straight one. So that this is our right triangle and this is the right angle. And we want to figure out what this angle is right here. The angle that your angle makes with the x-axis. So we know that this is 180. We know this is 225. That means to get from 180 to 225, you're traveling 45 more degrees. 225 minus 180 is 45. So once again, we're doing the positive and negative coterminal angles. A 45 degree angle is just halfway from 0 to 90, right? Because 45 is halfway from 0 to 90. And then a negative 45 degree angle is the same thing, but we're just going in the other direction. We're going downward instead of upward, so we start and go this direction. So negative 45 degree angle right there. positive coterminal angle, we can just do negative 45 plus 360. Or we could even do, what is that? That's 315. We could even do it with 720, you know, 2 full circles around. Etc. Okay, so then you have negative 45, and we want a negative coterminal angle, so that means we're just going to keep going more negative. So we just keep going in the same direction. You subtract another 360 degrees. Negative 45 minus 360 is negative 415. Nope. Was it 405? All right, so now we want to do the reference angle for that same angle. So here's our angle. Let's do a reference triangle by just drawing that straight line right there. Okay, so we want to find this angle right here. It's always going to be positive. It's always going to be between 0 and 90 degrees for a reference angle. Because it's really, if you're just thinking about this triangle now, once you make your triangle, you're only thinking about a triangle. Triangles only have angles that are 90 degrees or less. So there's our angle. We know that this is 0, and we know that this is negative 45. So the distance from 0 to negative 45 is 45 degrees. We don't care that it's negative, though. Another way to put it is you could do 0 minus negative 45, which equals positive 45 if you want an equation. But that starts to get complicated. That's why it's easier for me to just think about how far did I travel here. This is 0, and this is negative 45. I traveled 45 degrees. Let's see. 9. Okay, in the coordinate plane, sketch a negative 240 degree angle in the coordinate plane, and then find one positive coterminal. Okay, so it's just same thing, but with negative 240. This is negative 90, and then this would be negative 180. This is negative 270. So that means we're going to be somewhere in this quadrant. Okay, so we've got negative 180, and then 240 minus 180 is 60, so that means we're going about 60 degrees further. 60 is 2/3 of the way from, it's 2/3 of 90, so that means we're going 2/3 of the way from 180 to 270, because that's a 90 degree angle in there, so we're just doing 2/3 of it. And then we've got a negative 240 degree angle, and we want to find a coterminal angle. So this is negative 240, and we want to find a positive one. So let's add 360 to it. So that means we're going back the way we came. And coming back around, we're going a full 360. So negative 240 plus 360 is 120. And then a negative coterminal angle would be if we, instead of going back the way we came, we continued going in the negative direction. So negative 240 minus another 360 would be negative 600. So now we want to find the reference angle for this one. So reference angle, again, it's always the angle it makes with the x-axis. So even though it's closer to the y-axis, we're not using the y-axis, we're using the x-axis. So we know that this, we measured earlier, this is 60 degrees past 180 to negative 240. So this would be 60. Another way to do it would be to say, I guess you do 180 minus negative 240, and that's, oh no, that's plus. Well, hold on. Yeah, I think this just highlights the reason that it's better to just think about what's happening than to try and rely on an equation, because there's no equation we can really use here unless we start using absolute value, which is just going to complicate things. So let's just say it's 60 past 180 to get to 240. And then our last one like this, we've got negative 270 degrees. I know 270 is a multiple of 90, right? So this is negative 90, negative 180, and this is negative 270, right? right? So it's right on the y-axis. So a positive coterminal angle, well, I don't even have to add anything. I know that that's where 90 is, right? On a normal, when you're going in the positive direction, this is a 90-degree angle. A negative coterminal angle would just be to subtract another 360, negative 270 minus 360, what does that equal? Negative 630. And then our reference angle here is also going to be pretty quick and easy. What angle does this make with the x-axis? Well, we've been saying it over and over that that is a right angle, so that's a 90-degree angle. And then on our last slide, we're looking at the Seattle Great Wheel. It moves at a rate of 1 complete revolution per 4 minutes. So we're going to look at the angle that we would be at each position indicated after the wheel starts rotating. So here's where we get on, right? We're down here at 0 minutes, and we want to know what angle we're at 2 minutes. So at 0 minutes, we're here. At 2 minutes, we're going to be halfway, right? If 4 minutes gets us all the way around, then 2 minutes is going to take us halfway. It's going to put us right at the top. So that means we're at 90 degrees. We've traveled 180 degrees. But we want to remember that we're always measuring angles from the positive x-axis, from this line right here. So that's the 90-degree mark. And then the reference angle there, well, the reference angle for a 90-degree angle we just saw is just 90. See, 2.5 minutes. So if 2 minutes got us up here, that means 1 minute got us halfway there. So a quarter of this Ferris wheel is 1 minute. 1 minute, 2 minute, 3 minutes, 4 minutes, right? 4 minutes around. So that means here's 2 and here's 3. We're looking at 2.5. So we're halfway from 2 to 3. 45 degrees is halfway from 90 to 180. 90 plus 45 is 135. So this is going to be a 135 degree angle. And then the reference angle there, remember that's the angle this angle that we just drew in our heads makes with the x-axis. So we know that we went 45 from 90 to 135, and we know that's halfway, so the other side of that angle, the angle it makes with this 180 line, is also 45. All right, 270, that's right here, right? That's right at the bottom where we started. We didn't start at 270 though. See, our time is increasing, so that means we must have made 1 full revolution. We started here at 0 minutes, 1 minute, 2 minutes, 3 minutes, and 4 minutes to get to 270. 1 full circle. And then the reference angle there, just like we saw before, it's 90-degree angle. At 5 minutes, again, we already saw that a quarter of this Ferris wheel takes 1 minute. So 5 minutes is going to put us right here. So our degrees are, well, oh yeah, we want to keep in mind that these are increasing. So instead of putting 0 here, we're going to put 360 because those are coterminal angles. And then our reference angle, well, the line that x-axis the angle the x-axis makes with itself is going to be 0 degrees. Because this is a straight line. All right, so then when are we at 765? Well, I know that this is 360, and I know that a coterminal angle for 360 is 720, right? You're just adding 360 to 360. So that gets me back here, and I'm at 720. And then the difference between 720 and 765 is 45 more degrees, which remember is halfway from one axis to the other axis. So we're looking at a 45-degree angle right here. So this is going to be 45. And then how much time is that? Well, it was 1 minute to get to 0 degrees. And then it's going to be 4 more minutes to make a full circle back there. So that's 5 minutes to get 360. We saw that it was 5 minutes at 360. So add 4 more to make another 4 full circle. That puts us at 9 minutes for 720. And then earlier we saw that half a minute is 45 degrees, so it's going to be 9.5. And then the last one, 1080, is 1080 is a multiple of 360. 360, 720, 1080. And that is, so that's going to be right here. And we saw 360 here is 5 minutes. Plus 4 minutes would be 9 minutes at 720, plus 4 minutes would be 13 minutes at 1080. And then the angle that makes, we already saw that this is a 0 degree reference angle.